Hi friends, today we're gonna talk about convolution neural networks, which is can be known as CNN. Let's dive into the topic. Convolution neural network CNN is nothing but a neural network with some layers. What are the layers that we're gonna discuss now? Okay, in convolution neural networks, the first one is the convolutional layer itself. Okay, and then the convolutional layer consists of filters. These filters make the process start in this whole algorithm. CNN is nothing but an algorithm which is widely used for the image classification, face recognition, object recognition, etc. Okay, so what we generally have is in an image there will be a pixels. So in general, there are three different colors of pixels: red, green, and blue. Those are nothing but RGB colors. These combinedly form an image. Okay, so this convolution neural network consists of this concept, that is RGB colors, and it is widely used for image classification, image segmentation, face recognition, object recognition, etc. That all. And the first thing I forgot, it was introduced by Lee Kun in the year 1998. Okay, that's the basics about convolution neural network, and that means the start. It's just a start. Let's move into the next slide. Okay, as I said earlier, convolution neural network consists of layers, and if you ask me specifically what are the layers, then I will be telling you is three layers: convolution layer, the first layer, and the second layer is pooling layer, and the third one is fully connected layer. Okay, these are the three layers which is used for the concept of CNN. Okay, as you see the picture given, there is an input, that is a giraffe, and the pooling is done on that image, and after that is sent to the flattened layer, and after that fully connected layer, that is the third step. So the convolution will be considered in the pooling layer, and the whole thing will be done. After that, fully connected layer will be taking the chart, and after that output will be generated. Here we use different types of functions to analyze the output, to check which one is correct. Okay, here input is given. We know that basically we are humans, we can analyze ourselves, we are not machines, right? We have brain which are having neural networks, so we can able to say that the input is a giraffe, but machine go through this algorithm, convolutional neural network algorithm, and it provides different layers, this algorithm, and that are pooling layer, fully connected layers, all. After the completion of the whole process, the output which is given by the machine will be given to a activation function generally, and the activation function will be used to predict which one is the correct output from the given. Okay, from the generated one, all the outputs generated which have been generated, the correct one will be decided by the activation function. Here whether you can see or not, output, there is a box down there, and we are using softmax activation function. It is a type of one of the activation function used generally, and it is we are using softmax auto activation function. Then the given input is taken as three outputs, that is horse, zebra, and dog. This activation function gives the highest rate to 0.7, and that's to zebra. So this whole network, this whole algorithm, by introducing this algorithm into a model, the output generated for the zebra image is obviously the zebra, right? Okay, then let's move to the next slide. Okay, now let's discuss in detail about every layer here. As we know that in previous layer we can able to see the first layer is convolution layer, right? Then now discuss deeply about convolution layer. As I said earlier, every pixel, I mean every image have pixels, every pixels have colors, and those colors are decided using the binary values. Okay, binary, as you can see the statement, right? The digital image is a binary representation of visual data. Okay, so the binary values are used to decide which pixel has which color. See, we have three colors, so which color has to be there will be decided by the binary values. Okay, next, here the pixels are arranged in grid fashion. Generally, most of the graphical users, most of the designers who are interested, generally our students, we interest in designing part, we interest in graphics, so we all basically, these people are know that what is pixel, what is a binary value of the pixel, what are grid like fashions pixel, that all these people know. But for us, let me make you more clear. Pixels are nothing but the binary value storage things. With the help of these binary values, those pixels are lightened with a color. Basically, there are three colors: red, G, green, and B for blue, RGB colors. Okay, uh, these pixels are arranged in a grid-like fashion as the boxes grids. Okay, next, the bright color. If there is a one, the value is one. That is white. If the value is 0, that is black. Okay, and if the value differs between 1 and 0, the respected value will be, that means light black, light white, these type of colors will be generated. We can check the value here. Here 1.0 will give you a plain white on left side. You can check the box grids, one grid. Okay, here left side, on my left side there are values. In every grid there is a value. On my right side there are colors. Okay, let's dive into this concept, let's dive into this mathematics. Okay, 1.0 on the right side, for third grid it is white color, you can check if you want. And for 0.0 on the right side, on the left side, that box, I mean that grid will be a black color one. Okay, and for a 0.5 it will be the gray one. Okay, so these values will decide, and 0 for 0.6, and for 0.7, 0.8, 0.9, other type of colors, light and colors, light and white, or dark and light and black, different type of colors will be seen on the left side with respect to the right side value. Okay, this is convolution layer. Let's move to the next layer. In convolution layer, as I said in second slide, I said that there will be filters, right? In filter, convolution layer contains number of filters, and in that filters the operations takes place, convolution operations, and that will decides the output, I mean the that will decides the input for the next layer. But for this layer, this will be the output, as this output will be the input for the next layer, that is nothing but the pooling layer. In this convolution layer, number of filters are present, which is used to perform specific operations for the required input, which has to be passed to the next layer, that is the pooling layer. Okay, now pooling layer. Pooling layer is nothing but the it is an layer which is in the middle of the CNN. Okay, in this, what will happen is, it is reduce the spatial size of the representation, and it will decrease the computation speed and amount of weight. So what will happen is, it will faster the whole algorithm, it will make the model to move faster than the plain model. By using the CNN, it will make the model to learn or process the values more faster, since the computation is decreased, computation speed is decreased, I mean computation values are lowered, and weights are lowered. Okay, cause why is happening, cause there is a change in spatial size. Okay, So how it will be done is, in pooling, the values will be replaced with, all the values should be taken in the form of matrices. Okay, in filters they are all the taken in form of 4 into 4 or 3 into 3 matrices, and these matrices values are modified in pooling layer. Okay, in here in red color, what are the pooling functions? Pooling performs specific operations on every filter, okay, individually, and the functions are: the average of the rectangular neighborhood, L2 norm of the rectangular neighborhood, a weighted average based on the distance from the central pixel. These are the three functions where the pooling will be shown. Okay, let's move into that. Here what we are doing is, we are doing a max pooling. Okay, in max pooling what we will do is, here is the filter. Okay, we will consider 2 into 2 filter. I mean 2 rows 2 columns, that is 2 rows 2 columns, right? 2 rows 2 columns. We will consider 2 rows 2 column filter, 2 into 2 filter, and in that whole 2 into 2 filters, by we are having the 4 rows 4 columns here. So what will happen, we will get 4 2 into 2 filters, right? So in max pooling what we will do is, we will consider each 2 into 2 filter separately, individually, and we will take the maximum value of the whole filter. Okay, so on the upper left side, we are having 1156, and the max value of that filter is 6. On the upper right side, we have 2478, and the max value is 8. And down left side, 3212, max value is 3. And down right side, 1034, max value is 4. So what we'll make is, the all the taken max values are being given to a separate filter, that is 2 into 2 filter with the max value. Okay, so this is known as max pooling. This is the most popular pooling technique used in pooling layer. Okay, let's have a look at the last information here, last point. If we have a activation map of size W into W into D, a pooling kernel of spatial size F and stride S, then the size of output volume can be determined in the following formula. So these are the conditions. These are the conditions of the provided filter. In the previous layer, the filters which are taken as the output of that layer and given as input to the pooling layer, with depending on the filters which the previous layer has provided, we will use this formula and we will get the output of the pooling layer. Okay, okay, why pooling? Okay, we have just discussed pooling, the convolution layer, etc, etc. So why this layer is most important? The reason is, the pixels, generally the image are of, if the image is of big size, it will take more, it has more weights, and it will give huge computation time, it requires huge computation time. So what we will do is, because of the pooling, as we can able to see on the screen, the left side image is deduced into right side image with the help of pooling. So we can observe that the pixels of the image are being smaller. Okay, the decrease, they are just decreased, the image pixels are being decreased, but we have to make sure that the image doesn't change, but the pixel size decreases. That means the image size will be decreased, obviously. These will help in faster the process of the algorithm. Okay, next, fully connected layer. This is the third layer. In this, generally, neural network, obviously neural network name resembles, there is a network of neurons in this algorithm. So in the neurons are fully connected with all the neurons. I mean, neurons are connected with another neuron, so that the flow of flow of outputs will be moved to the one neuron to one another neuron until we get the final output, until it reaches to the final layer, output layer. Okay. Generally, we can able to see is fully connected neuron layer, neuron networks in this CNN. Okay. Matrix multiplication as well as bias is computed for this value. Since the value will be passed from one neuron to another neuron, that is nothing but the matrix multiplication followed with the bias. Okay, those computed value will be followed from one neuron to another neuron. The fully connected layer, what will do is it will map the input and output. I mean, the input one which is given by the user and the output which has to be generated, has to be generated by the model. These two are represented with the help of FC layer, that means fully connected layer. Next, here we can able to see the how the neurons are being connected from one layer to another layer. In this, number of neurons are connected, and one neuron shares the information with another neuron, and whole thingly the neurons will forward the content to uh, forwarded neuron, and those neurons will be for until unless the output is generated, that value will be forwarded. Okay. Next, here the whole CNN network is separate. In this, what we'll do is we will take a image of a cat. In after that cat, we will take the image, we will go through the convolution layer. So after that, max pooling, we can do how many times it needs. That means we can do convolution layer process and max pooling process, that how many times which we required, which is help to decrease the computation, decrease the computation and weight of the image. So the number of times you make this, it will decrease the computation and spatial size and the weights, so it will be easy to predict the output. And then after, once it has been flattened, when the input has been through this convolution and pooling concepts, I mean layers, the output will be a much flattened one. The number of times these layers continues to work, the output will be, which is generated from these two layers, will be the most flattened one. And once the flattened layer is given to neural networks, right, fully connected neural networks, that is feed forward neural networks, that means the information will be fed to the forward ones. It will goes to until the output layer is defined. Once the output layer is, once the value reaches the output layer, and there will be an activation function, and the thing which satisfies, which value satisfies the activation function, that is considered as the output, right? So at the output layer, there are different values such as cat, dog, wolf, etc. But with the help of a activation function, that it can be softmax, any other activation function, doesn't matter, that activation function will be deciding the which one will be the output for this model. Okay, this is the concept of convolution neural network. Thank you.